All right, let's get started. We've got a great session for y'all here today. I think the third installment in a series that we're doing around Temporal Cloud. But I just wanted to thank you all for joining today. Really excited to get this session moving. I'm excited for our guest, Sergey, who I've known for about a year now. And man, he's some brilliant stuff in deploying software and building some really interesting things. And so hopefully this is really valuable for you all. So welcome to the event. So again, just one last thing before we get started. This is part of a series of talks that we're doing around Temporal Cloud. We've already talked about, automation in Temporal Cloud, API keys, and how do you basically kind of like automate kind of creation of user, the namespaces, all these things that we're doing there. The way we think about availability and disaster recovery in Temporal Cloud was the last session. We're going to introduce a new feature called global namespaces coming up. We talked about that. So how do you have like a, multi-region failover out of the box push button? This week, we're going to talk about the custom persistence layer for Temporal Cloud. I won't get too deep into it. Sergey and I will talk a lot about that, but there's there's a lot that we've done and innovated at the storage layer for the temporal server that allows us to basically scale pretty damn far and deliver some latencies that I think are just out of this world. So some really interesting things that we learned, and Sergey's going to do that. And then I guess it's 2 weeks from now. Oh, next week we are at a company offsite, so I don't have to do this next week. We're going to talk about the costs of Temporal Cloud, and if all this is interesting to you, what's it going to look like? I think it's a fairly great thing, and then of course it's a nice flow, and then if that all looks good, we'll help you migrate. So with that, I'm going to actually, you know what? I'm going to share the screen one more time because we don't have to do that. I want to invite our guest, Sergey, on. So, Sergey, can you join me? You there, buddy?
Hey, Jim. Yeah, I'm here.
Hey, Sergey, how are you today?
I'm very well.
It's good.
I'm in Redmond, Washington. I think it started raining a little bit outside.
Yeah, I don't even have to ask you your past. You live in Redmond, so I'm gonna guess you worked for one of a couple different companies, right? So,
right.
So hello, Sergey. So just real quickly, just to level set with everybody that's on, what is your title? What do you work on here at Temporal Labs or at Temporal? And how long have you been with Temporal?
Yeah, so Temporal, we don't have like fancy titles, or we don't have like really title. Everyone is kind of SD in engineering. I joined almost like 3.5 years ago, and I joined pretty much when we started building cloud. So I've been leading architecture, our cloud service, a hosted offering.
Right. And just real quickly, I can do this too, but like, how do you describe Temporal Cloud? Like, what is Temporal Cloud? I love to hear it from your point of view, Sergey, before we get into like what we built and why.
Well, I'll give a kind of provocative answer to this question. Sort of my long-term view is at some point in the future, just like people when they need a software project, go to GitHub and create a repo and put their code, and they don't think twice. I hope that Temporal Cloud will be like that, where you want to build something, you just go create a repo in GitHub and you create the namespace in Temporal Cloud, and off you go. It just works for you.
Yeah, well, I share your vision, Sergey, and I think we're heading in that direction. It's one of the reasons I joined. I think it simplifies a whole lot of things, and the durability of Temporal is just amazing. But I think from a productivity point of view, oh man, there's some really interesting things that can. I think the future looks great, So
yeah, it's all about writing happy path code. So I want to express how I want system to work and my logic to work. I don't want to write on 20 various like unhappy cases like error handling. This is usually like difficult part and less tested part.
That's right. As Smitty, one of our solutions consultants, say, code like you're in college. I love that statement because it's so true. Like, forget about all this crazy failure scenarios. Forget about like coding around, blocked queues or failed databases or multi-service transactions or like just remove the complexity. Love it. I wish I had it because I'd probably still be a developer. I think the stuff I hated to do was comment, unit test, and coding for failure. The three things I hated. But anyway, I'll digress. So
you can go back always.
I know. Well, yeah, with Temporal, it makes it really easy, right? So Sergey, today we want to talk about the custom persistence layer we built for Temporal Cloud. And so I think once Temporal Cloud's been available for how long now? When did we first launch this?
It was, let me see.
Oh, man,
It was
I
early
just stumped you with the
2021.
I just stumped you with the best question.
Yeah, it's literally like 3 years that we had our first customers. We call them design partners. We're still building it,
Right.
but we had customers that are willing to be on the cloud
Yeah.
and use it before it was actually fully built.
And then at, like true like public availability, it's only been about 12 or 13 months. I think, I joined a little bit after. And so I think we're up over 800 now customers and I don't know, thousands of namespaces on there. So we've learned a whole lot, right? And so this whole concept of building a kind of custom persistence layer, how did this come about for us, Sergey?
Yeah, so I have a few slides to kind of
Great.
visualize, and some of them I presented at QCon, San Francisco, and some are just for this talk. So kind of whenever you start something, building something, first you need to answer the question why, right? And for a service like this, there are two options. There's a single tenant model where you allocate physical resources for a customer, and the multi-tenant model where you allocate virtual resources and then put the resources of multiple customers to a single physical resource, the multi-tenant model. And what we discovered, pretty much nobody wants single tenant, because a single tenant, you have to pay for kind of capacity, whether you use it or not. And every single customer of ours wants to pay a consumption based. So that if this is their traffic, they want to pay for what they use, not for capacity. And also what helps when you put many customers on the same physical resource, the headroom for like spike in traffic, for like sudden growth of traffic is kind of combined across all these customers. And you have much higher headroom. So it gives you a better experience overall. And so for this multi-tenant system, you have like high throughput, and you need to worry about noisy neighbor and isolation, performance isolation for customers. And that goes to persistence, that usually is the hardest part. Just like show that this is not a kind of just a simple graph. This is like screenshots from our dashboard from like one of our clusters we call cells with see like multiple customer namespaces. They go up and down at different time, and combined they use the capacity.
So Sergey, before you carry on from here, I think anybody who's on the call right now may be struggling with the same thing for their own application. I mean, I think Temporal is just an application as well. We're trying to deliver it as an efficient service for our customers. I think people on the phone or on the call, I guess, on the Zoom, I guess, are probably thinking about some of the same things. Like, and I understand from a multi-tenant point of view, we want to actually make it more like efficient and cost sensitive for, our customers, basically, right? But there's kind of like the amount of headache it's going to be to build this thing versus kind of like the thing itself, right? And like, I think all the reasons are there. How did you go through the conversation around, like, does this make sense for us to do this or not? Or was it just kind of like a foregone conclusion because we knew we were just basically going to be a service company?
So we evolved to this. So we started with, this is like simplified architecture, what we call the cell for like, we call V1, V2 version cell. Like there's a lot of machinery, the compute, the temporal services, there's like infrastructure services for managing certificates, connectivity, ingress, durability. And then there's like, it's small in the diagram, but the database, like in reality, this is usually the hardest part because the compute thing, it's kind of mostly stateless. Yeah, you can have state in memory, like so it's semi-stateful, but database is what really like guarantees durability of your state of your application. And the bigger you grow the cells, the more multi-tenancy you put, the more challenges you have, like with the shared database, to make sure you have we support high throughput with low latency and good isolation. And then you start thinking, how do I what do I build on top of this layer?
And so, Sergey, just to level set everybody, I mean, the whole concept of temporal and durable execution is like your code can execute if it fails at any point. I don't know, a process fails, or I don't know, like a timeout happens, or you're blocking call, whatever. Like and say a server fails, you can just spin this up on another machine somewhere. So what we're persisting is basically that execution, correct? I mean, that's the data that we're talking about here.
Yeah, that's what we call durable execution. We give this illusion that your execution, like your call stack essentially, it's an illusion, but it requires a lot of writes, a lot of state, like every event to be persisted so that can be transparently replayed. And you can continue, you can shut down your application completely, kill your workers, and then restart them, and they just continue as if nothing
Right.
happened.
Yeah. So that
And,
is
and
the
that,
data.
that's high, it creates heavy load on persistently.
Yeah. Yeah. It's a lot of, there's a lot of writes, from what I understand, right? So heavy on the right side. So,
Right.
so that's kind of the top level. What were kind of our goals, from a, if I think about multi-tenancy and these sort of things, I think one of the first things people talk about is like noisy neighbor. They get concerned about, running in the same environment as other people. Like, what are some of the things you had to kind of think about as you were kind of going down this path from that angle?
Well, the first challenge is scale, and I want to cover like three techniques we use. They're nothing new. They're like well known in the database world for like decades. Like the first challenge is scale. Right, we have customers that just have traffic that can grow like for special days, like Black Friday or like New Year's Eve, things like that, Super Bowl. And when you talk about like scaling database, like there's a scale up and scale out. And Temporal supports database of both types. Like you can use MySQL or a Postgres and just keep increasing the size of your server. Or you can use like scalable, like horizontally scalable database like Cassandra type, where you can just add nodes and it grows. But at some point, even like this horizontally scalable database, they reach the size where they become less comfortable with kind of large cluster size. Scaling back down is usually a challenge. Like it's easier to add nodes and to remove because you be very careful with like reshuffling data. And the first trick we applied, we decided to shard databases. Instead of having one massive database, why don't we have multiple smaller databases we can add dynamically, or we can resize them independently? And that was the first thing to do to support just large scale that some of our customers needed. And they were self-hosting and I was struggling with kind of reaching the scale. And that came to us so that we would support that scale reliably.
So just real quickly on this context, I'm personally, I love database and database technologies, quite honestly, Sergey. So what is the shard key? Is it basically like workflow execution? Is this dynamic so that we have stuff like sprinkle across multiple different shards? Like, what are we sharding on?
So there are like two things we did. First of all, Temporal has a notion of shard inside history service. So in this case, like the first step was just to distribute these shards across multiple databases instead of putting them into one massive database. But then later on, like a year or two later, we also started disaggregating data and putting different parts of state. So like we call it mutable state, where there's a state of execution, like one massive table, but then there's history, lists of events for each workflow. And we started adding, like, we can use this database just for histories. Like, for example, for like massive scale for like New Year's Eve, we add databases just for history. And then when they expire, when retention is over, then we can safely remove those databases without moving data around. So kind of, we ended up doing both.
Yeah, cool.
Right, so this is kind of simple, easy to understand, basic sharding. The write-ahead log was probably the biggest impact in terms of scalability and latency. We talk about that Temporal is a write-heavy kind of software server code, and for every update, every event, we need to write to the database. So the change, again, like well-known technique from database world is instead of writing directly every time, we can just quickly put it into like append only write-ahead log so that if anything happens, if this thing crashes, we can read and recover. And then write to database is only like periodic checkpoints based on timer, based on number of updates, so which allows us to amortize a batch of writes to a single checkpoint while not losing anything because we can always read the previous checkpoint and replay the events that haven't been checkpointed since.
So I know like some commercial databases do things kind of like this, Sergey. Our choice to kind of build this, is it because we're kind of doing many things at once, or is basically like it wasn't this viable in a single solution, like off the shelf software, right? Why do we have to build it, right? I guess is what I'm asking.
Well, by reducing the write rate, we reduce the size of the database we need. So that made it the stability of database with scale generally goes down, right? So like if we have small database, it's much better performed. But then also it's much cheaper, right? So like then we can give a better economics by amortizing these writes in memory. But also because we manage it in memory, like before, instead of just blindly writing the database, we have better fine-grained control over like noisy neighbor problem. We can control like latencies. We can prioritize this traffic. So we're much more intelligent about what we're doing here.
Cool. That's great.
And so like the previous picture was always oversimplified, changed to like in the third and fourth generation of cells, we call them, we added this layer, sometimes referred to as journal layer, where we write some machinery that we take off the shelf, like on a bookkeeper, zookeeper pieces, and a lot of the custom code. So that's how it's evolution of our cell architecture over time. And then the third technique is related to this notion of retention. So usually like workflow runs, in most cases, workflows are relatively short-lived, like seconds, minutes, like maybe hours. Some workflows are very long-lived, like they are forever, like fire every month. But the majority of cases, they're relatively short-lived. But then after they complete, there's still a retention period. And so like workflow completed, but you want to be able to see history. You want to like do something with it. Sometimes people export this information. And so what happens, people want to have long retention, and in the cloud, we support up to 90 days after a workflow closed. Usually people use like 7 or 30 days for debugging and kind of going back. But all these histories of closed workflows that say closed in the last 30 days, they are massively clog the database. There's a lot of state closed workflows. It's essentially documents stored in the database. And again, like the obvious technique is to start moving things out into like object store. So when workflow closes, execution completes, we take its history, move it to object store like S3 or like GCS or the Azure Blob Store, and then they're still accessible. So the pointer to them changes from pointer to like the database table to a document in object store. So they can still be loaded, maybe with slightly higher latency, but it doesn't matter. They're already completed. There's no like live execution. But massively reduces the amount of state in the database, and again, allows us to keep databases smaller and more efficient.
And are we setting the policy for like time to offload, or is it like amount of time, like, or does the customer set that, Sergey?
Oh, we set it transparently. For a customer, it's like I can pick retention time, and data is available up until that they have the hits, right? But under the covers, we manage moving this data around, and we smooth it out. We don't want to have like spikes of access, right? So like we jitter that behind the scenes.
Right.
Like if you spike with the huge traffic, like in New Year's Eve, we don't want to like have a same spike of moving data out. We want to spread it over time.
Yeah, we're much more efficient because we have that control. And then what is the format of this data? Is it like I don't know, some common open source format? Is it kind of like stuff that we kind of did particular to Temporal? Like, how are we storing it?
So the core format is the proto, that is like open source. The history format is all public. In some cases, we use JSON, but if I remember right, we store it in proto for efficiency.
Protobuf, right? I think so. Yeah. Yeah, it's fairly fast and well known. So
yeah, we use the same for export. Like in cloud, we support, you can configure, point to your S3 bucket and say, I want closed workflows history for compliance to be put there. And then you can store them forever for like whatever, 7-year regulatory time, not to your retention time.
Right. So there's kind of the 3 big pieces here, right? There's sharding, there's the write-ahead log, and then there's kind of tiered storage. I think there's the big 3 like pieces that we pulled together, right? What was the trick kind of pulling? Was there like a trick pulling this all together, Sergey? Because I mean, I think each one of these things I get it, but is there like was there something kind of from a higher level that we struggled with, or from a lesson learned that we kind of can convey to people?
Well, I think the write-ahead log was the most daring, like challenging, because you're building this thing that needs to work even better, even more reliable than the underlying database that has, I don't know, millions of lines of code. I think that was the big undertaking to make sure we have all this machinery working, because it's not just the code that writes to this write-ahead log. You need all the control plane logic to deploy, to monitor, like making it actual reliable, highly available cloud service. I think that's the high bar that you need to hit this service.
And for the write-ahead log, I mean, I presume it's our own system that we built to basically chunk off and write data. Are we using any like publicly available streaming solution to do that, or is it just we coded it because we needed the control?
We use some pieces and we even like change implementation over time. So we ended up using like the bookkeeper as like low level store and like bookkeeper for coordination, but everything else is like on top of it written by us. Because there's a lot of like nuances, like how do you want to flash, like very, very many nuances there. You want to have full control of that code.
And so, so Temporal Cloud today is available only on AWS. Is there plans to make this available in other places, Sergey?
Well, absolutely. GCP is coming this year for sure. I don't want to give any exact date because software dates are very dangerous. And I'm pretty confident, even though we don't have like concrete plans, but I'm pretty confident like Azure will come after that at some point. So like the major clouds, we need to support them all.
And we typically get questions around this, Sergey. People running their application in one cloud provider and then like servers running somewhere else. What's your like kind of? Should people be concerned about that from a latency point of view, or is it kind of like, I don't know, it just seems to work pretty well?
It's interesting you mentioned that, because we have some like especially like enterprise customers, some like big internet companies. They come with this assumption: oh, if I talk to your cloud from like my other environment, the latency will be worse than my self-hosting. And we've heard that from like several customers. They were surprised that the latency actually went down and were much more stable, because again, they were running self-hosted with this kind of scale up, like say MySQL or like different characteristics, even with Cassandra. But then because of this layer, custom persistent layer, we have much more stable latencies. And they discovered that there are smaller latencies, even though they kind of sometimes cross cloud boundaries.
Right. And so there was a question in the chat now. I mean, at what scale do you start needing sharding and wall and tiered storage? And let me ask it in two different ways. At what scale do you kind of need Temporal Cloud? And I'll just presume that's one side of it. But if I'm an app builder, when should I start thinking about sharding and doing my own custom database? Kind of same question, two different ways.
Well, your first question, Temporal Cloud, you start getting value right away because you don't need to run this machinery, right? And that's kind of the big motivation for people. Either I need to deploy this kind of coolant themselves with all this monitoring myself and build a team, which is expensive, or just get it kind of for free.
Just to get all the software and do the deployment and the machines, that alone. Yeah, I got you.
Yeah, so the first the question is easy to answer in terms of when it makes sense. So like we use like the internal measure is state transitions per second. At what rate it makes sense. So I think if you running at like several thousand state transitions per second, you kind of can tune it and make it work. When you get into like tens of thousands, it's much more challenging. Like you will need to think of something like that, managing your database very carefully. Back, I would say 18 months ago, we ran an expensive test of target was million state transitions per second, called MPS million per second, and it was expensive to run for like a few hours. But we showed to ourselves that we can handle million state transitions per second, and that is not possible without these kind of techniques.
Yeah, and we're doing these things today. Like we have these huge spikes of data for like, we have a customer who has a whole bunch of work that happens on New Year's Eve. And, I think we had a bunch of people sitting there, not out partying, waiting for the cluster to fail, and everything was fine, right? Like, so, and I think, we've gone through some fairly large, massive, like web scale type loads with Temporal Cloud that we've pushed the bounds, I think safe to say, correct? Oh yeah.
Right, and I think sometimes people underestimate the control plane aspect of it because yeah,
Yeah.
you can hand deploy something, but it needs to be repeatable, it needs to be reliable. You don't want human operator to make a mistake and bring something down. So everything needs to be automated and tested, like
Yeah.
including like deploying a write-ahead log components and switching to a larger one. All of this takes investment.
Yep. There's a related but unrelated question, Sergey. Is the data that we store encrypted?
Oh yes, it's always encrypted at rest.
Yeah. Yeah. So everything's always encrypted. I think there's another kind of key feature that we have in Temporal, which I found incredibly interesting. And that's the data converter. If anybody's really interested in like, holy wow, like the way data, like encryption and privacy of data needs to be implemented in an application, I would go look at that pattern and what we've done. I think it's truly incredible. I think it's innovative and truly awesome. Like you hold your own keys, it gets encrypted in your application. We never see it ever through workers, through the server, through storage. So if I know the person who asked that question, go check out Data Converter and all the great documentation we have around security. It's kind of truly amazing.
That's my
Actually,
favorite feature, and I mentioned it in a
me
couple
too.
of my talks because when they talk to like security people at some like major banks, and then they realize actually they can encrypt everything, and they don't have to trust us at all with
Yeah.
their data. They're like,
Yeah.
oh, much easier.
Yeah, it's funny. It's one of the ones I'd like to talk about as well, because I think it's innovative, quite honestly, the entirety of the approach. I think it's pretty awesome. So, um, hey, there's another question here. Do we have any benchmarks of, Temporal Cloud versus, with our stuff, but like running SQL or Postgres or Cassandra underneath this?
I'm sure we do. I'm just not kind of
Yeah,
current on because we don't have to test like constantly like, and compare because they're kind of different classes of running the software.
right. Yeah. Yeah, I think we see people thinking about cloud running like their own temporal service on one of these databases, and then they'll look at like results between the two once they kind of move into cloud. We'll work with people, for the first month to see if like they're getting the right results. Typically we do, because it's not just the database, it's also the control plane, it's all the things that actually go into this, right, Sergey? So it's yeah, we're happy to work with people if they ever wanted to compare what they're working with, kind of the way that we're doing things in cloud. One of my favorite surprises over the past couple months as well, Sergey, has been this whole latency thing, which I think is kind of tremendous to see those kind of like, it's like a 3 or 4x better almost sometimes. So
Yeah, and our solution architects are much better equipped for those conversations, like engineers like myself in
yeah.
the trenches.
Or like lowly marketing people like myself. I don't know. I don't know what I'm talking about, dude. So I think that was most of the questions. There was a question about, okay, so is any of this available in open source temporal?
No, none of this is available, and it kind of doesn't make a lot of sense because this all, like as I mentioned, for multi-tenant kind of scale, is already not a trivial task to run basic temporal. Kind of running all this machinery, like I said, requires control plane. That would be like very confusing to try to
Right.
self-host this stuff.
Yeah. I don't know. The way I always think about this is like a temporal provides the server and all of the capabilities. It's like the big brain in the sky for your application. I like to think about it. And then the 6 supported SDKs with other community SDKs, so you can code for these capabilities within your applications. That's temporal to me.
Right.
Deployment of the service, like this brain in the sky, if we want to call it that, there's tricks around doing that. And the same API we use to deploy MySQL underneath or Postgres or Cassandra correct me if I'm wrong, but it's pretty much the same API as what we're using, right? I mean, that's kind of like the point of like the surface area between temporal and this stuff that we're talking about. It's that is the surface area, right, Sergey?
Yeah, like in the big scheme of things, so there's this persistence interface where you plug in your MySQL or Postgres or
Right.
whatever you decide to implement yourself. Like majority of these just plugs in as kind of like a database. Of course, there are multiple layers there, but yeah, we use the same persistence interface for that.
Cool.
So like you said, like the whole execution logic, it's exactly the same. Like the whole
That's
programming
right.
model looks exactly the same. But when it comes to persistence behavior, persistence characteristics, scalability, latency, this is where these investments make a difference.
Yeah. Yeah, and this investment is because we're also delivering a world-class service with low latency and massive scale. And like, yeah, there's things that we had to do that, like any company would have to do. Temporal is still temporal. Like,
Yeah, 100%.
still an amazing environment and is still an amazing experience. We just want to make it as rock solid simple. I think we started our conversation here, right, Sergey? I mean, the future of this is like, how do we make this so that you don't have to think about any of this stuff, right? I mean, that is kind of where we're going on this side of things, right?
Well, it's even more than that. So like what we want to get to at some point, like it will take some effort, is that you can start self-hosting whatever, and then you can dynamically migrate the running application to our cloud, let's say in AWS. Then you decided to have a better deal in the kind of Azure. You migrate without stopping the application live running with same latencies. And then you decide, oh, actually, I want to bring it back to my on-prem self-hosted, migrate live application without interrupting it. To some point in the future, we'll get to this state where you'll be able to move around running application from on-prem to cloud and back. And
yeah,
that's the vision to get there.
And it's to me pretty exciting. So, cool. When using cloud, how are updates to the temporal service applied? I presume this is probably about like, upgrades to the software itself, Sergey.
Yeah, like I gave several talks on this point. I think one was at Replay and a couple other conferences. That's where we build this control plane that kind of organizes the cells into rings and deployment rings from like least critical to most critical, and gradually rolls out these upgrades behind the scenes, like one during the time or batch of cells at the time. So like rolling out a new version may take like 2 weeks for us just to be safe. But it's all automated. We just say, okay, this version is ready. We start rolling it out.
Well, cool. Well, Sergey, I think we hit all the questions that were kind of like directly related. People were asking like, do we use Kafka for event sourcing? No, we that's a wholly different topic, and we're happy to engage. Somebody was asking the data converters and the workers. So it's all client side. So absolutely go check out the documentation on data workers if somebody's, or data converter. Even if you're not interested, I'd read it because it's pretty awesome. And then there was another one about, long-running workflows and schema migrations, which is a little bit off topic, and we're happy to talk about that in
but
chat.
I think to this point, temporal is backward compatible. Like there's no impact on any kind of evolution of schema or version of temporal. Your application is oblivious to that. It just keeps working.
That's right. That's right. Exactly. And so I think this is one of these things you get really familiar with, and you start to see the power of temporal as you get closer and closer to it. So Sergey, the last thing, would you mind if I share the screen really quickly?
Oh, totally.
All right, y'all. So where, oh man, am I sharing the right thing? I don't know. I'll do this off the cuff. Sergey, thank you for doing this today. As always, I enjoy these conversations. I look forward to seeing you next week in live. We're a virtual company. We are all remote. So every once in a while we all get together, and lucky for us, that's next week. So Sergey, I look forward to seeing you. Safe travels and all that. Thank you for doing this today very much.
Oh, that's my pleasure. Same to you, Jim. We'll see you next week.
Yeah. And if anybody has any questions about kind of how we built this, what we build, data converter, all these things, oh gosh, by all means, please join our community Slack. You'll hear from all of us. And probably, I don't know, 9 out of 10 times it's Max himself, like the founder of the company's in there. Can't keep him out of Slack. He's like probably one of the most active. So if anybody does want to actually engage and ask more questions, that is really one of the best places. But I invite you all to the last 2 sessions of this series. We're going to talk about if cloud is interesting to you. Like I'm going to tell you right now, it's probably going to be a lot less expensive. And I'm not just talking about the operational side. This whole thing around multi-tenancy, the way that we can run this, we can actually do things at scale at less cost, in my opinion, and provide a better experience. So we're going to talk about that in the next session. And then beyond that, if you've made it through all the sessions, then you're ready to migrate. We put the migration one at the end. So y'all, thank you for joining. And thanks again, Sergey. And everybody have a great day.
Thank you all. Thank you, Jim.